In this video, we look at application of the remainder and the factor theorems. It's a continuation of the previous video on remainder and factor theorem. So we want to find the remainder when the given polynomial x raised to power 5 plus 2x raised to power 4 minus 3x squared plus 2x plus 7 is divided by one linear function x minus 2 and the other one x plus 1. Note that we can use the long division to find the remainder, but now we want to use the remainder theorem. And the remainder theorem states that if, for example, if you are given f of x is divided by a linear function x minus a, then if there is no x term that remains in the remainder, and then we have f of a is equals to r, then r is the remainder. So in this case, for the first one, x minus 2, our a is actually 2. So what we do is 2 to get 2 raised to power 5 minus 2 to minus 3 2 plus 7, and this one will give you this is 32 minus 32 minus 12 plus 4 plus 7, and this 32 minus 32 will cancel, and 11 minus 12 is negative 1, and therefore our remainder is negative 1. Our remainder is negative 1. So on the other hand, if we divide with the linear function x plus 1, you will note that this is the same as x minus 1, and therefore our a is negative 1. And we know that by remainder theorem, r is equals to f of a. So again, we replace negative 1 with, x with the negative 1. So we get that plus that minus 3 times negative 1 squared plus 2 times negative 1 plus 7. And this will give you the remainder, which is negative 1 plus 2 minus 3 minus 2 plus 7. This 2 and 2 will cancel. This is 7 minus 4 is 3. So the remainder is 3 using the remainder theorem. Sometimes you might be given a different example. For example, find the numerical value. Find the numerical value of a. Find the numerical value of a if we have x raised to power 4 plus ax cubed plus x squared plus 2 has a remainder of 2 when divided by the linear function x minus 2. So in our case, we are saying that by remainder theorem, r is equals to f of a, and if we should not confuse this a and the a that we are solving here. So it implies that our a is 2. Therefore, f of 2 should give us 2 raised to power 4 plus 2 cubed, that is 8, plus 2 squared 4 plus 2 should give us the remainder, which is 2, by remainder theorem. and this is 16 plus 8a plus 6 is 2. This will give us 8a. 8a is the same as 2 minus 22, and 8a is the same as negative 20, and therefore a is negative 20 over 8, or negative 5 over 2. That is the value of a in the polynomial x raised power 4 plus ax cubed plus x squared plus 2, where the remainder is 2. Another example, show that x minus 1 squared, or x minus 1 is a factor of, you want to show that, you want to show that x minus 1 is a factor of x cubed minus x squared minus x plus 1. So if x minus 1 is a factor, then it means that the remainder will be 0. Recall that we said that if x minus a is a factor, then f of a is equals to 0. So in our case here, our a is 1. So it means that if it is indeed a factor, then 1 cubed minus 1 squared minus 1 plus 1 should give us 0. And this is 1 minus 1 is 0, minus 1 is 0, 0 is equals to 0. So indeed, x minus 1 is a factor. X minus 1 is a factor. Another example is, suppose we have two factors, x minus 1 and x plus 2, and then you are told that the two are factors of x cubed plus x cubed plus ax squared plus bx minus 2. So the factors are x minus 1 and x minus plus 2. So find the numerical values of a and b. So if the two are factors, then it means that the remainder should give us 0. The remainder is 0. If the two are factors, the remainder will give us 0. In other words, if we replace a with, let's say the first one is 1, we shall get 1 cubed plus 1 times a plus b times 1 minus 2 should give us 0, since x minus 1 is a factor. The other one is f negative 2, since we have x plus 2 as a factor, then a is negative 2. So we shall have negative 2 cubed minus, not really minus, but plus 4a minus 2b minus 2 should give us 0. So if this is the first equation and this is the second equation, from the first equation you can see that a plus b is equals to 1. And from the second equation, we can see that 4a minus 2b is equals to 10. Because this is negative 8, negative 2, negative 10. So you can say maybe by 4 here to get 4a plus 4b is equals to 4, and then we solve by elimination. 4a minus 2b is equals to 10. So if you subtract, you get 0. 4a minus 4 is 0. 4b plus 2b, 6b is equals to 14. And therefore b is 14 over 6 or 7 over 3. On the other hand, if a from 1, a is 1 minus b, which is the same as 1 minus 2, that's, and a is at that. So that way you have utilized the factor theorem and the remainder theorem to solve some problems.